Hello and welcome to U08.PW2 Properties of Waves, where we will try to solve sample problems using the wave speed equation. So let's do this. The wave speed equation is V equals F lambda, which really is just speed of a wave or velocity equals frequency times wavelength. So using that equation, we can find the velocity, the frequency of the wavelength, with our given variables. So let's try out a problem. A piano string is tuned to the note A above middle C. The frequency of the string is 440 Hz. The speed of sound is 240 meters per second, and we need to find the wavelength. So what we are going to do is we are going to take our equation, V equals F lambda, and we're just going to change it around to solve for wavelength. So it's going to look a little something like this. So what I did there is lambda equals velocity over frequency, and we have both velocity and frequency, so we are just going to plug in there. So that would be 240 Hertz, 240 meters per second, over the frequency, which is 440 Hertz. And now we're just going to take out the calculator, and we're gonna try this. So 240 divided by 440 is going to give a nice number right there, which is going to be 0.54, or we're just going to go 0.55, a round up. So that is our answer, and that is the wavelength of that problem right there. So let's do another one. A sound wave is moving 1,150 meters every 4 seconds. The sound wave has a wavelength of 2 meters. Find the frequency. So this is essentially the same problem. All that we're doing, that we have to do, is find the first find the velocity, then we can find the frequency because we already have the wavelength. So if we do remember that velocity equals the change in displacement over the change in time. So using that, we will have velocity equals 1,150 meters over 4 seconds. And that will give meters per second once we divide that. So let's see what we get. We get 287.5. So that is our velocity right there. So what we're going to do now is take the original speed equation, and let's just drop it down here really quick. And what we have is 287.5 equals the frequency, or we'll just go the wavelength 2 and F. So we're just going to divide that 2 out, and we will get our frequency. So that would be 287.5 divided by 2, and we get 143. Let's see, 143.75, and that will be Hertz. And so let me go back up here and make sure I put meters for that wavelength, because we always need our units of measurement. And yeah, so that's how we do it. We use the original equation, velocity equals frequency times lambda, and we use that, and we need 2 given variables to find the third missing variable, and that is how we find the speed of a wave. So thank you very much, and I hope you enjoyed this.